Assalamualaikum and hello everyone. Today we are going to learn about application of phase diagram in food industry. Are you excited? Yes, let's start our class. I am Nufarha binti Mansur and I will explain about the introduction of phase diagram. When we talk about phase diagram, we are really talking about how certain thermodynamic variables like pressure and temperature affect the phases that exist in a system. In many disciplines of planetary science, phase diagrams are useful analytical tools because they allow you to quickly see how phase assemblages change in response to changes in pressure, temperature, chemical potential, or any other set of intense variable. There are a few types of phase diagram. The first one is unary phase diagrams and the second one is binary phase diagram. Unary phase diagram is the simplest form of phase diagram. The three phases of a substance are divided by equilibrium borders in this diagram. A binary phase diagram depicts the equilibrium of two substances in a system. Temperature and chemical composition are the variables in most cases, with pressure being constant. A metal and a compound or two compounds can be the two substances in this case. That's all from me. Then we will learn about the concept of the phase diagram with Nur Sharyani. Goodbye everyone. Have a nice day.
Hi, I'm Sharyani and today I would like to present about concept of phase diagram. So what is phase diagram? Phase diagram is graphical representation of physical stage of a substance under different conditions of temperature and pressure. A typical phase diagram has pressure on y-axis and temperature on x-axis. Then, when we cross the line or curve on phase diagram, the phase change can be happen. In addition, two stages of the substance coexist in equilibrium on the line or curve like this. For your information, this is graph of general phase diagram, and then based on this graph, the red line divides the solid and gas phase. So this is represent sublimation and deposition. Then the green line in this graph show that divides the solid and liquid phase. So represent melting and freezing. The blue line show that divide the liquid and gas phase, represent vaporization and condensation. After that, based on graph are also two important points on this diagram. First is triple point and second is critical point. Typical point is the point on a phase diagram at which the three stages of matter like gas, liquid and solid coexist. Then critical point is the point on a phase diagram at which a substance is distinguishable between liquid and gaseous stage. This is all for me. Thank you.
So, are you guys clear about the concept of phase diagram? So, to make all of you clear about phase diagram, don't worry because I am Shahira and my friend Afika will explain more about the concept of phase diagram that we apply in food industry. One of the concept of phase diagram that we apply in food industry, which is dehydration of food. What's mean by dehydration of food? Dehydration of food materials is often carried out by air drying, allowing free evaporation of water with decreasing volume in changes in food structure. At high level of solid, air-dried food may exist above the glass transition, like dehydrated of food, or as glassy solids such as food powder produced by spray drying. The process of food dehydration involves simultaneous transfer of mass and heat within the food and the medium used to transfer energy to the food. In food dehydration method that supply energy to the food using media other than hot air or some other gas may be required to move moisture away from the food. Dehydration also is efficient food preservation method that reduce the water content and the water activity to levels that do not allow growth of microorganisms. Next is crystallization of food, which the process of forming crystal from solution is known as crystallization. It is important unit operation for separation of solid in dissolved from in a solution by making use of the principle of saturation solubility, temperature or solubility and temperature. It is important to know the characteristic and quality of the crystal in different food, such as butter, margarine, ice cream, sugar, and chocolate, all contain different type of crystal. The function of crystallization is to generate a certain texture or appearance that make the product acceptable.
Hi, my name is Amira Norafika. Next, I will continue about other application in phase diagram. Before that, remember, phase diagram is responsible for the relationship between phases in a system as a function of temperature, water and other composition. Okay, let's learn about the next application of phase diagram, which is in ice cream. We always enjoy a scoop of ice cream, but we do not realize how ice cream actually is a very complex food. They involve interaction between water, sugar, and temperature. That's why phase diagram is formed. Let's take a look at this graph. It's a phase diagram of salt and water. At the horizontal line, it represents concentration of salt, NaCl. As you go further to the right, it means 100% salt. While it goes further to the left, it means 100% water. And vertical axis, it represents temperature. The red area is an ice and salt water phase and were called freezing point depression. Generally, we know that water freezing point is at 0 degrees Celsius, but in ice cream, there are a mixing of salts and water, therefore making the freezing point of water is below than 0 degrees Celsius. The structure is disturbed. This is what happens in freezing point depression. Next, we have clusterization in a cereal-based product food, such as cookies, cakes, and flour. This is because they are rich in proteins and starch. There are two ways to make the glass transition process occur, which is reaction with water and temperature. For example, during dough mixing, starch and gluten proteins interact with water molecules. Hence, water acts as a plasticizer, providing molecular mobility and allowing a glass transition to occur. The glassy material, which is the flour, transforms into a dough. We can see that it goes from glassy state to rubbery state. Glassy state is a region of limited water mobility, while rubbery state is a region with higher water mobility. Next, let's take a look at this graph. This is a phase diagram of glass transition mediated by temperature. As the temperature increases, the starch will undergo glass transition called gelatinization. They will go from glassy state to rubbery state, but when the starch is cooled, it will turn back to a glassy state.
Hi, Assalamualaikum. I'm Nisha Mila, and I'm sure you guys already understand the concept and application of phase diagram in food. Now, let's conclude what we have learned. In conclusion, we can conclude that a phase diagram is important as it provides relationship between phase in a system as a function of temperature, pressure, and composition. Phase diagram is a graphical representation of the physical states of a substance under different conditions of temperature and pressure. A typical phase diagram has pressure on the y-axis and temperature on the x-axis. A phase transition is the transition from one state of matter to another. There are three states of matter, which are solid, liquid, and gas. Then there are two examples of the phase change in food, which are dehydration and crystallization. For application, there are two example application of phase diagram in food. Firstly is the application of the phase diagram in ice cream. Ice cream is a very complex food and that involves interaction between water, sugar, and temperature. Secondly is the application of the glass transition process in cake. During dough mixing for making cake, starch and gluten protein interact with water molecule. Hence, water acts as a plasticizer, providing molecular mobility and allowing a glass transition to occur. The glassy material, which is the flour, transforms into a dough. Okay, that's all explanation from our group about the topic application of phase diagram in food. Thank you.